All right, let's try to simplify another exponent expression that again looks very overwhelming, but if you take it step by step, you can do it. So when I first look at this, I immediately think, oh goodness, where do I begin? But I'm going to go ahead and start with the exponent that's on the outside of the parentheses because I know that I want to distribute that. I want to use the, let's get my pen here. I want to use the power of a product property. So I'm going to go ahead and write that out. Product. Okay, so what that means is I'm going to make sure this exponent of 2 is given or is distributed to every term inside the parentheses, every factor. And I'm using the word factor because I can see that everything inside the parentheses is being multiplied. So I'm going to start with the numerator of my fraction. I'm going to first make sure that it's given to the x to the 4th power. And when I say given, I mean I'm going to multiply it by that exponent. So that becomes x to the 8th power. Now I'm going to make sure it's given to the y to the negative 5th power. I'm going to multiply the exponent of 2 by the exponent of negative 5, which is y to the negative 10th power. Now I'm going to make sure it's distributed to each of the factors in the denominator. So let's start with the x to the negative 3rd power. I'm going to multiply it so it becomes x to the negative 6th power. And last but not least, I'm going to make sure that it's also multiplied by y to the 4th power, which becomes y to the 8th power. Okay, so step 1 is done. Now I no longer have an exponent on the outside of my parentheses. So now I see that I have 2 operations going on. I have multiplication and I also have division. Since I don't have any of the same bases in the numerator, and I also don't have any of the same bases in the denominator, I don't believe I can use the product of the powers. And the product of the powers is where you can add the exponents. But I can't do that because I have a base of x and a base of y in my numerator. So that means I cannot add those exponents. But what I can do is I can look at the x to the 8th power in the numerator and the x to the negative 6th power in the denominator. And since those are being divided, I can subtract my exponents. And that, just in case you don't remember, is called the quotient of powers property. Okay? So the quotient of powers property says that when you are dividing and you have the same base, you are allowed to subtract the exponents. And I can do the same thing for the y's. So looking at my x's, I know that 8, I'm going to go ahead and just show my work right here. 8 minus negative 6 is actually going to be positive 14 because when I subtract a negative number, I get a positive number. So my 8, or not my 8, my x becomes x to the 14th power because I did 8 minus negative 6. I'm going to do the same thing with the y's, but now I'm going to subtract the negative 10 minus 8. If I have a negative 10 and I subtract 8, that gives me negative 18. So now I have x to the 14th power times y to the negative 18th power. And I did both of those things using the quotient of powers property. So now, looking at what I have left, I'm almost finished, but I'm not allowed to leave a final answer with a negative exponent. Because I have that negative exponent, I need to make sure it's positive. So I'm going to just use the negative exponent property. I'm just going to say negative exponents. and negative exponents, if you recall, I can rewrite y to the power of negative 18 as its reciprocal with a positive exponent. So instead of having y to the negative 18th power in the numerator of a fraction, it's the same thing as 1 over y to the positive 18th power. So what ends up happening is I get as my final answer in the numerator x to the 14th power over y to the 18th power. And that's really because I'm multiplying them together. And remember, if you multiply anything by 1, you get that number. So my final answer, as simplified as I can get it, is x to the 14th power over y to the 18th power.